Okay, what we had left off with on was we've been talking about ways to describe a function. So we've talked so far about domain and range. We've talked about positive, negative, zero. We've talked about increasing, decreasing, and constant. And we've talked about extrema. We have a little bit more to talk about in regards to extrema. So I'm just going to rehash kind of what we had left off talking about in regard to extrema. So this is just going to be just me rehashing what we had talked about in the previous lesson, just briefly, just to make sure that we're kind of all on the same page, because it's been a day or two since we've looked at this stuff, probably. So we noted that there were two types. We have maximum, or the plural maxima, and minimum, or the plural minima. The maxima we said was the top of the hill. The minimum we said was the bottom of a valley. We said there were two types of max and mins. We have locals and globals. The local was any max or min, but to be a global, for the maximum, you have to be the highest point, and for the minimum, you had to be the lowest point. And then I think we did an example where I drew a graph and we picked out which ones were the locals and absolutes, or globals, right? What I want to talk about today is how we can use our calculator to do this if we're not provided a graph. So suppose we want to find the extrema and the intervals of increasing, decreasing, and constant for the function here. I'll write it as y equals x to the fourth, 2x cubed, minus 4x squared, minus 3x plus 1. So, the way we're going to do this is we're going to use our graphing calculator. If you have your graphing calculator with you, I invite you to take that out and follow along. If you don't have your graphing calculator with you, that's okay, just kind of pay attention. If you get stuck trying to do the homework, you can always refer back to the video where I walk through how to use these again. If you don't yet have a graphing calculator, talk to your mom or dad or whoever you need to over the weekend and remind them that I must have a graphing calculator for this class. We should go out and get one. The one you want is probably a TI-84. A TI-30 is not going to cut it. Not going to cut it. Probably good for your chemistry class. Not going to cut it for your math class. So, the first thing we want to do is turn our calculator on. The on button is located in the lower left-hand corner. When you turn your calculator on, it should bring you to the home screen. Your cursor should be flashing somewhere on the home screen. Mine is blank. If you were working on something prior, you probably have some, some calculations on there already. If we want to graph something, where we need to go is to the y equals menu. Notice in the upper left-hand corner, in gray, is the y equals button. Let's go ahead and press that button. First thing we should check for is up at the top where it says plot 1, plot 2, and plot 3. Does everybody see that on their y equals screen? Notice how none of mine are highlighted. If you have any of these highlighted, we need to unhighlight them to start with. So what does it highlighted look like? It would look like this. So to get that unhighlighted, we just can use our up and down and left and right arrows, move our cursor on top of that specific plot, and then press enter to unhighlight it. So everybody's plot should look like mine do here at the top. If this is the first time you've opened and turned on your calculator, it should be set that way already. If you're using a hand-me-down calculator for somebody else, that may or may not be the case. So quick check, because it's going to create problems graphing in the future. Next thing I'm going to do, if I have anything in these y equals slots, I'm going to clear that information out so I can type in my new formula. So to do that, I'm just going to press the clear button. The clear button deletes the entire row. And then I'm going to continue scrolling down and make sure that there's nothing down here in any of these y's. So I went all the way to y equals 10. All of mine are blank. If this is the first time you've turned on your graphing calculator and you just bought it, that should already be the case. If you have a hand-me-down graphing calculator, that may or may not be the case. So I notice in this y equals menu, the y part of my equation is already there for me. And the equal sign is already there for me. So the only part I need to worry about typing in is this x to the fourth plus 2x cubed minus 4x squared minus 3x plus 1. So I'll start by typing this in from left to right. So I want to type the x first. The X button is right here next to the green alpha button. So I'll press that button and it'll put an X on my screen. The next thing I need to do is I need to get this exponent of 4 on there. To type an exponent, I'm going to press this caret up button that's right below the clear button. When I press that button, it moves my cursor into the exponent. I can then type the number 4. Notice after I've typed this number 4, my cursor now has a right arrow on it. What that is telling me is that to move out of the exponent and back into the main line, I need to press that right arrow key. So if I press that right arrow key, you see my cursor is now moved out of the exponent and back into the main line of text. Questions so far? Okay. So then I'm going to type in the plus. So the plus button is here in the lower right hand. And then the 2. And then I'll go back and type the X button again, which is right next to the green alpha button. And then I'll choose the exponent button again, which is this caret up command. Type the number 3. And then press the right hand arrow to exit back out of the exponent into the main line of text. Then I'll type in the minus 4x squared. So I can do minus 4x. And now I could type the exponent the same way I did before. But for squareds, there's actually a shortcut that allows us to type it a little bit faster. Notice here, 2 down from the alpha button is the x, 3 down from the alpha button is the x squared button on your calculator. If I press that, it puts a squared on there and automatically moves my cursor back into the main line. Either way of doing it is fine. You can type it as an exponent, or you can use the x squared command. Either is fine. They will do the same thing. I am lazy and prefer to type less buttons, so I use the x squared button there. Next, I'll type the minus sign. Notice there is a separate minus key and negative sign key. They cannot be used interchangeably. If you mean subtraction, you better press the subtraction button. If you mean negative, you better press the negative button. They do not do the same thing on the calculator. You'll get errors if you try to use negative where you mean subtraction, subtraction where you mean negative. And then I'll type in my 3, my x, and then my plus and my 1. Is anybody still typing this in? I know I went really slow through that, but I'm assuming that this is everybody's first time ever touching one of these things. So if it's not, and you feel good about this, I apologize for going so slow, but hopefully that feels doable. Everybody's good to hear? What I want to do next is make the calculator graph this equation. But before I do that, I want to tell the calculator how to build my XY axis. So I want to know how far down the y's go, how far up the y's go, how far left the x's will go, and how far right the x's will go when I build my XY axis. Like if you're going to graph on your own, the first thing you draw is your XY axis and you put tick marks on it out to a certain amount, right? My suggestion for you guys is when we do this, we're just going to do a standard amount. So we'll do 10, 10, 10, 10. 10 to the right, 10 up, 10 to the left, 10 down. The calculator already has that option built into it. To access that, I'm going to press this zoom button on the top row. And I'm going to pick the option Z standard. Z is short for zoom. The zoom standard is the standard 10 by 10 window. So you can scroll down to that with the up and down arrows and press enter, or you can just type the number 6 because it's command 6. And at this point, it should move you to the graph screen, and the calculator should draw the graph in for you. Pretty neat. So, if we look at this, we can see some extrema here. How many maxima do we see? One maximum. It's this spot right here where my pointer is, right? Is that local or global? That is a local. The reason it's a local is because there are points on the graph that are higher than that one, right? All the stuff on this part is higher. All the stuff over there is higher. Everybody agree with that? How many minima do we see? 2. There's one here, and then one here. Everybody agree with that? Okay. If I look at the minimum on the left, is that local or global? Global. Very good. And the one on the right then is local. Very good. Okay. So this is good. I was able to figure out how many maxes and mins and what type they were just by looking at the picture. If I want more information, though, say I want the actual coordinate where those minimums and those minima and maxima are, the calculator can provide this information for us as well. So the way to get this information is I'm going to go into the Calculate menu. So I'm going to press the second button here in blue, and then the Trace button on the top row of the calculator. That's going to open up the Calculate button, or the Calculate menu. All of these commands in the Calculate menu are commands we would do to a graph. So this is all stuff you would use on a graph. If we're, say, looking for the local maximum, which of these commands sounds like the relevant command?
0.
Maximum. If we're looking for the local maximum, we should look for the maximum. Okay, so I can scroll down and press enter on the maximum command, or I could just type in the number 4. Now you notice that it's brought me back to the main screen, or my graph, and at the bottom it's going to ask me some questions. So the first question it's asking me is for left bound, then the calculator is going to ask me for a right bound, and then it's going to ask me for a guess. So what it's saying is, I need to know where on the graph to start looking for this point at, that's left bound, where to stop looking at this point, or looking for this point at, and then where is your best guess. The guess doesn't really matter, the left and right bound definitely do. So you notice also what happened when you press this button, you have a cursor now on your graph. See this little flashing spider looking thing on the graph? So I'm going to start by moving that somewhere to the left of that local maximum. So that would be anywhere on this part of the graph is left of that local maximum. You guys agree with that? Anywhere over there is fine, so I'm just going to use my left and right arrows to move the cursor to where I can see that it's in the area that I need it to be. Once I have it where I want it, anywhere on this section that's left of the maximum is fine. It doesn't matter where. Anywhere is okay in that section. Okay with that? So it just needs to be on the left side of that maximum. So if you have a maximum that goes up like this, it just needs to be somewhere on that left side of it. Once I have it where I want it, I'm going to press enter. And you'll notice when I do that, it asks me a new question. It says, right bound. Yes, sir. Yes, sir. And then I am going to then move my cursor over onto the right side of that maximum. So over in this section here. So I'm just going to use the right arrow key to move my cursor. So it's somewhere over there. That looks good to me. I'll press enter again. And notice the question has changed now again. It now is asking for a guess. My suggestion is to just press enter wherever you're at. The guess doesn't really matter. Technically speaking, the calculator will find that answer a little bit faster if your guess is good. But a little bit faster, we're talking like microseconds faster. It's not even worth your time moving the cursor to a better location for your guess. Just press enter again. What? The location of the maximum. So you just move it to close to where you think it actually is. But it doesn't really matter. You don't have to provide a good guess. You can just give any guess and it'll be fine. So once I do that, notice on the bottom of the screen it now says maximum, and it supplies an x value and a y value. That is the coordinate of the maximum value there. So I'm going to go ahead and write that down. I'm going to round this to 2 decimal places because I don't feel like writing down all of those decimal points. So keep in mind, what I've written here is an ordered pair. That's an x-coordinate and a y-coordinate, not an interval, even though it looks the same as a notation. Let's find these locations of these 2 minimums now, or 2 minima, I should say. So I'm going to go back and repeat the same process, but this time instead of picking the maximum command, I'm going to pick the minimum command. So remember, to access that calculate menu, we press second and trace. We'll select this time the minimum command. And let's find the global minimum this time. So the left bound is somewhere on this section of the graph. So I'm going to scoot my cursor over to that section. That looks good, and press enter. then a right bound, so that's somewhere on this section of my graph. So I'll move over to there. That looks good. I'll press enter. And then I guess I'll just press enter again. So again, it spits out my coordinates for my minimum. I'm going to write these down, rounding to 2 decimal places, because I just don't want to write down that many decimals. Those of you with your graphing calculator, take a minute and try to find the local minimum now. So you're just going to repeat that same process, but this time you're looking for the local minimum. I will follow you up in just a minute, but I want to give you a chance to try to do it on your own, as it's good practice. You coming to see me? Okay, what's up? Okay. So let's press the mode button, and your mode is set in parametric. It's just something you'd be doing in calculus. We're going to be in function mode for all year in this class. Yep, that'll change automatically when we're in function mode.
So you're going to mode for that?
Yeah, and it'll stay that way now.
Yeah,
once we've set it to function mode, unless your brother takes it and uses it again, it'll stay that way until you change
Yeah,
it.
because I don't know.
Yes, yeah, certainly you're looking at that going, that's not at all what my screen looks like. All right, here we go. Second, trace, minimum. Scroll, 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 scroll. Right here, looks good. Press enter. Right. That looks good there. Press enter. That's a good guess. And I get 1.06, comma, negative 3.03, rounding to 2 decimal places. Right, so local minimum is like any minimum that's not global. So this one is the global one, because it's the lowest point on the graph. This is just the local. You find it the same way with the calculator. You just use the minimum command. You just have to pick your left and right bounds on the left or right of this one. So you're picking your left over on this section and your right bound over here. You still just use the minimum.
Like, when I get this thing to go back on, it's not touch screen.
Okay.
So like, I put that little line right there on that one, and I put my right line over on this one, and I just put the guess right there.
Okay. So that's fine. So you had it on the right, left and right of this.
Mm-hmm.
Now you
Like
could
on,
have
like on
okay.
these 2 lines.
Yep, I understand.
Okay.
You could have potentially run into problems as it could have found this one
Yeah.
instead of this one.
Yeah.
The fact that you put your guess near this one saved you.
Oh.
If you want to really be sure, make sure it's on like this little section for your left and this section for your right.
So when I'm finding the maximum one, I have to put it on the maximum.
Well, you want to put it on either side. Like if I'm just ignoring everything other than the part that makes the hill,
Okay.
I just want to have it on the left side of the hill and the right side of the hill.
Okay. But when I'm finding a specific part, I have to put it on.
If I'm looking at this minimum, I want it on the left and the right of it. I'm ignoring everything else.
Okay.
Does that make sense?
Yeah.
Okay. And if you're doing it, if you're like moving it to a guess, that helps if you're not quite sure. Like that'll help. All right, let's reel it back in here, folks. So if I want to then find my intervals of increasing and decreasing, notice that there is no constant interval here, right? We just have increasing and decreasing. My increasing sections go from my global minimum up to my local maximum. You guys agree with that? That this section from global minimum to local maximum is uphill? Okay. So my global minimum starts at negative 2.24, and my local maximum is negative 0.32. So that's that section. And then I have another increasing section here at the end that goes from my local minimum all the way off to positive infinity. My local minimum is 1.06 and then positive infinity. So once I know these coordinates for these local, or for these mins and maxes, I can write my intervals of increasing and decreasing pretty easily. Let's do the decreasing sections. So my first decreasing part goes from negative infinity down to my global minimum. My second decreasing section goes from my local max to my local min. Okay with that? The last thing I want to talk about is end behavior. Well, last thing today anyways. And this is just describing what the ends, or the arrows at the end of the graph, are doing. Yes?
Is there a way to get your graph back if you hit clear on accident?
Yeah. So just press the graph button on the top row there at the very end.
Oh.
So let's say we have this graph here. So if I wanted to describe what the arrows are doing here, I have two arrows, right? How would you differentiate the names of these two arrows? What would I call, say, this arrow? How about the left arrow? Right? Everybody agree with that? What's that arrow doing? Okay, points down. How about this one? I'll call that right arrow, points up. Okay, so that's really easy, right? Is it that easy? No, it is that easy. The problem is we don't write it in words, we write it in symbols. So let me describe to you what the symbols are. When we say left arrow, we'll say as x approaches negative infinity. Why? Because when I go from left to right, we're talking about the x's. Shh. And the left side of the x-axis is where negative infinity lives. When I say points down, I'm going to write y goes to negative infinity because the up and downs is the y-axis and going down is towards negative infinity. So if I talk about the right arrow, that's the x-axis going this way. That's where positive infinity is, right? So I'll write as x goes to positive infinity. And when I say points up, up is on the y-axis, and going up on the y-axis goes towards positive infinity. So write y goes to positive infinity. That's it. So again, the notation isn't even difficult, right? The symbols aren't too bad because they literally are just describing exactly what you've written in words when you looked at the picture. Everybody okay with that? All right, let's stop here.